Okay. Diagram shows a parabola which has an equation y equals a 1/8 x squared and another parabola q which is the image of p under a reflection in the line y equals x. So this line here is going to be our y equals x. Draw it in if it helps you remember. So parabolas p and q intersect at the origin and again at a point A, and the line L is a tangent to both p and q. So coordinates of the point A is where those two lines intersect is on the line of reflection, which is y equals x. So if we take this equation and we again replace the y with an x because they're interchangeable on that line, and then solve, we get x equals 1/8 x squared. So 8x equals x squared, so that means x is going to have to be 8, which makes sense. We could also say that x could be 0, because if you do some rearranging and so on and so forth, 8 times 0 is the same as 0 times 0, and 8 times 8 is the same as 8 times 8. So we've got our two values, but obviously the 0 part we've already got, because that's where it intersects at the origin. So the 8 is the one that we're after, and to find the y coordinate, we're still on the line y equals x, so we're going to go 8, 8, nice and simple. Okay, so the coordinates of the point A are 8, 8, 2 marks. Write down an equation for q. Now we know that q is the reflection in the line y equals x of this, so we're just going to, for the line, if you're reflecting something in the line y equals x, you just swap over the y and the x values in the equation. So we're just going to rewrite it as x equals 1/8 y squared. Yeah, that's all we need to do there, and that's the reason it's only worth 1 mark. Give a reason why the gradient of L must be -1. Well, if you look at your equation, the point where it touches there and the point where it touches there are mirror images in that line, which means that that line is the perpendicular bisector of this line, which means that that's 90 degrees, which means that if that's a tangent, then that's a normal, and so on and so forth. And we know that if two lines intersect at a right angle, then the gradient is going to be the minus the reciprocal. So in this case the gradient is 1, so the gradient down here is going to be -1. So that's your reason. Given that the line y equals -x plus c intersects the parabola at two distinct points, show that c has got to be greater than -2. So I think I'm going to need a different bit of paper for this because I don't think we've got room. So we are going to go, we've got the line y equals -x plus c, and we know it intersects the parabola p at two distinct points. And the equation of p is y equals 1/8 x squared, and we know that they intersect at two distinct points. So if they're intersecting, then we're just going to make them equal to each other. So we're going to go with -x plus c is equal to 1/8 x squared, and then we're going to rearrange it a little bit to make it easier to work with. We're going to have 1/8 x squared plus x minus c, and in fact I might make it slightly easier for myself and I might multiply these through by 8. So I might go with x squared plus 8x minus 8c is equal to 0, and see if that helps matters. So then we know that for there to be two distinct points where it intersects, then b squared minus 4ac, the discriminant has got to be greater than 0. So we're going to fill in, that's our a is 1, b is 8, c is -8, so b squared, we've got 64 minus 4 lots of 1 times by -8c, because that's our c value over here. It's confusing slightly because they've used a c and we're working in c's, but we'll get there. So if we work that through, we've got 64, and then we've got 4 lots of -8c, so we're going to have plus 32c is greater than 0, so we'll have 32c, and then we'll take the -64 over here, and then c has got to be greater than -64 over 32, which is the -2 that they asked for. Okay, so that was the question. Given that the line intersects, show that c is greater than -2, which is what we've done, and then find the coordinates of the points at which the line L touches the parabolas, no differentiation. Okay, so the coordinates of the points where the line touches the parabolas. So we've been working with the equation P and the line L, and we know that they only touch in one place at the moment. So that makes it a tangent. So instead of it being b squared minus 4ac is greater than 0, for a tangent we're actually looking at equals 0. So if we're working on just that one tangent, then we're going to have c equals minus 2. So if c is equal to minus 2, then we can go back up here and we can change this around. So we can have text, and instead of having minus 8c, we can have minus 8 times minus 2, which is plus 16, which will make life much easier because now we've got actual numbers to work with. So if we make that equal to 0, and then we just bung that in some brackets, that's going to be x plus 4, x plus 4. So x has got to be equal to minus 4, which means if we then look at the equation, we can get ourselves the y value. So if we know on the parabola that our y value is 1/8 of our x value squared, minus 4 squared is 16, an eighth of 16 is going to be 2, so we've got that, and that's for the point P. That's where it intersects the point, where it touches the point P, the parabola P, sorry. So that's going to be that point there. Now the point down here is going to be the same thing in Q, which means it's that reflected in the line y equals x. So again, when we're reflecting the line y equals x, all we do is we swap over the coordinates. So we're going to have x equals 2, y equals minus 4. So there are questions on hyperbolas. Hopefully that's given you a pretty good idea of how they work and how you're going to get those marks. They're not actually as bad as they look, despite the fact that they tend to be the last question. So have a bit more of a practice. You've probably got some more papers that you can work through, and have a crack at these ones yourselves and see how you get on. And hopefully by the end of it you'll be feeling a little bit more confident with them.